Welcome back. We are going to continue working on absolute value. Actually, we're getting down to the end of this topic. I want to just make certain that we address some inequalities. I want to be sure that folks are able to kind of connect the dots between absolute value, graphing, and set notation. I want to make certain that that all comes together for us. So here we go. I have an example here of the absolute value of x plus 7 is going to be greater than 10. Now, when we have the positive side of that, right, it's going to be it's real straightforward, right? We just do the x plus 7 and then it's greater than 10. All right. Now, when we have the negative value, because we have a reflection around the 0 on the number line, right? 0 you have is the kind of the cutting off point, and then you go up 1, 2, 3, 4, and then coming to the left you go -1, -2, -3, -4. Because we have that reflection around the 0, we have to go ahead and actually flip our inequality sign almost as though we're multiplying it by a -1 in order to, whoops, I don't want to equals. In order to be able to address our -10 here on this equation. Remember, this one way or the other, this came out to be this became greater than 10. So if this was a -10, then we have to deal with that. If it's the absolute value of that would wind up being, it wind up being when you take the absolute value of this becomes the positive again. So that's how it becomes a greater than in this case. All right, so I'm probably confusing people. I hope I'm not. So at this point, we're going to go ahead and I'm going to subtract. And I want to be real clear. When I'm subtracting, I don't need to worry about flipping the inequality. If I were multiplying or dividing by a negative number, I absolutely would have to worry about that. But I am not doing that at this point, so I have an x is going to be less than -17. And here I have, remember this is both of them, not just one. Here I have x is going to be greater than 3. So on my number line here, and I'm just going to freehand it, so I apologize that it's not going to be really perfect. So there's 0, let's call that 3. And down here is going to be our -17. All right, and I'm going to change my color here so that it's a little easier to see what's going on. I have the largest part of this is going to be the -17. So here I'm going to have this. It's going to be a paren because I don't have the equal sign underneath there. This is not a greater than or equal to. This is just strictly less than, not a less than or equal to. So I'm going to say everything going this way. All right. So now I'm going to have a negative infinity, right? I'm going to have a negative infinity and a -17. All right. And here I'm going to go ahead and do the same sort of thing. My x is going to be greater than 3. So again, I'm going to be, it's not a greater than or equal to, it's greater than, so it's going to be a paren. Since it's greater than, it's going to be going away from 0. It's going to be going towards positive infinity, right? So in this case, our interval notation is going to be 3, right? And it's going to be paren because it's not equal to, and then I have that positive infinity, and we use a paren because that is a concept. Okay, so here is just kind of the initial explanation of how this stuff works. I want to actually I have it typed up elsewhere here. I want to make it look a little nicer. So I'm actually going to minimize this and go with what we have as far as, let's see here, I'll move this over. So this is a case where you have an equal sign. We deal with the negative, right? We have to multiply through by that -1 in order to clear off the negative sign in front of the absolute value and on the -45. So we wind up getting the absolute value of 10 plus 5x is going to equal 45. And then it becomes just a straightforward problem at that point, right? Because we're still dealing in equals. All right, we get down to the fact that our solution would be negative 11 and a positive 7, right? And you can kind of look at this, pause the video, and look at the steps that we went through in order to get there. But it's important to realize that you are going to have to think about that a little differently when we get to the inequalities on this. I'm going to take the exact same thing, and this time I'm going to make it be, this is less than, strictly less than, and we have negative out front here, and we have a negative value here. All right, so very first thing we're going to do is we're going to multiply through by a negative 1. Whenever we multiply by a negative number, you have to flip that inequality. So even before we start doing anything to solve this problem, beyond getting it down to the absolute value, I have to flip my inequality. All right, so this is now a greater than, or greater than, not a greater than or equal to, but greater than, and now we're going to split it apart. Well, here's the positive side. This is exactly the same here, except I've taken off the absolute value bars. In this case, however, I have to flip the inequality sign again, right? Here I flipped it because I was multiplying through by a negative 1. Here I'm flipping it because I'm dealing with the negative side of the number line. So here we're going to go ahead. I wind up with both of those. Subtract 10, so we get down to 5x. In this case, 5x is going to be less than negative 55. And here my 5x is going to be greater than 35. Divide both sides by 5 so that our x is going to equal, or is going to be less than negative 11. And here our value is going to be greater than the 7, right? So if you take a look, and I'm not sure if I can do this with this, right? All of this going this way, and all of this going this way. Those are the values that I can, that I am going to be saying are my solution. This part in between here is not a solution. It's not included. Here's my absolute value. Has been sorted out, so I've got my negative infinity up to, but not including, negative 11. And here I have the bottom edge, the lower bound is going to be my 7, and it goes all the way up to positive infinity, which again is a concept. It didn't include the 7. So here's how we wind up having this look like what it is. All right, so I'm going to move this forward. All right, so I'm faced again with an absolute value. I've got an inequality on this. So I am going to deal, again, this and this are going to be exactly the same. I just took the absolute value bars off, no big deal, right? As soon as I take the absolute value bars off and I deal with the negative side of that, I have to flip that inequality. So this is how it becomes greater than. All right, so we're going to add 5 to isolate that 2x, right? Divide both sides by 2 to get to x. X is going to be greater than or equal to negative 13, which means we're going to face this way, right? We're headed this way. We don't include the 13, right? So this is still a paren. And here I'm going to, same kind of thing. I'm going to be facing, my x is going to be less than 7. I don't include the 7. So everything in between here, all of this is my solution. All right. When you talk about it, this is our interval, and remember, this is one of those cases. Context matters. This is not a point. This is an actual interval, saying we're not including those actual values, but everything in between them is captured in that interval. Okay, so I'm going to go just a little bit further here. I'm going to have my absolute value of 1/4 x, or I could say x over 4, minus 2. is going to be greater than or equal to 6. When I go ahead and split this out, I'm going to take this, I'm going to have the negative be over on this side for this one, just so that it's easier to see. Here, I'm just bringing this down, right? I take the absolute value bars off. And here, I'm again taking the absolute value bars off, but because I'm going to the negative, I am going to have this, it's going to have to flip. So instead of it being greater than or equal to, now it's less than or equal to. We're going to add 2 to both sides so that we get x over 4. And then we're going to multiply those by 4 in order to get to x. We don't want 1/4 x, we want x. So we multiply, we get to x is greater than or equal to 32. And x is less than or equal to negative 16. So here if I go to my negative 16, right, on my number line, we're going to have the square bracket. And everything is going this way because it's less than the negative 16, and it's because it equals, we have the square bracket, not the paren. And on this one, we have the 32. Again, it's a square bracket, and it's going to be facing to the right because we are going greater than or equal to the 32. So in this case, our interval notation, we would have negative infinity to negative 16. And on the 16, we're going to have that square bracket because it is included. And here I'm going to have the square bracket 32 to infinity. And then again, I have a paren simply because that is not a number. It's a concept. All right. I'm going to stop here, and we should hopefully be finished with this topic for the moment.